Hello, dear students. How are you all? I hope you all are doing great and amazing. I hope you had an awesome summer holidays, and I hope now you all are refreshed and energized for the new academic year. Before I begin, I'm Justin D'Souza. This is my channel Best Math. Before I start, I just want to thank all of you. The past few months ago during the exams, so many of you watched my videos, and so many of you liked, shared, and commented. And I was reading through all the comments. There was so many positive comments, positive feedback. I really appreciate each and every single student who took the time to write all the positive things. Thank you so much, because that really motivates me to do more. And all those who subscribe to my channel, and every one of you, a big thank you, and I really appreciate it. And now we will begin with the first lesson, that is graphing exponential functions from the module 5, which is the first module in the term 1, that is exponential functions. Now let us begin. Over here, the learning objectives are graphing exponential growth functions and to graph exponential decay functions. We will learn about both of this. And the keywords in this lesson are exponential function, exponential growth, asymptote, growth factor, exponential decay, decay factor. Now then, let's start with the exponential growth functions. There are few important things. You can read through this. There are few important things over here. This equation, okay, you can write it in y equals bx. Anything in this form, you heard this so many times, exponential. Anything in this form is an exponential function, where this b is base and it's a constant. It will be a given value. It won't change. It will be, say, 2 or 3. Whereas this x value keeps on changing. It's a variable, independent variable. You can give any value and you can find the answer for different values. Okay, so this is an exponential function. For growth, right, this base must always be more than 1, whereas for decay it must be from 0 to 1. That's it. So if you have 1, then anything to the power 1 will be the same thing, so it's just a flat line. So what happens is, whenever it ranges greater than 0, less than 1, it is a decay function. The decay would be something like this, going down. Whereas a growth function, when it's more than, the base is more than 1, it goes upwards. And what happens is, in this particular exponential functions, you will have asymptotes. The part of the line, the graph, it will be approaching some value, but it will never touch that value. Say it's 0 over here. It will go towards 0, but it will not touch. My diagrams are not that great because it shows it's touching, but in reality, it will be very close, see, like this, but it will not touch, in fact. Okay, so those points, those lines where it approaches are called asymptotes. Now we'll look at all of them. Let's see over here. Graph function, that is f of x, or you can even get y equals to, okay, it's the same thing. F of x equals 2x, find the domain, range, y-intercept, asymptote, and end behavior. Let's do this now. You know how to graph, make the value a table of values. And over here, let's assume values less than 0 and greater than 0. So say from -3 to 3. And you need to put these values in the calculator, say over here, 2 to the power -3. You need to do this, type it. Same way, do it for -2 and you'll get the answer, and you will get all these answers. And then you can graph it out. Now, if you're thinking this will take too much time, you have you have scientific calculators, and you can easily do it in the calculator by pressing mode and then 7 for table. And now what you need to do is type the function. It may be y or f of x. It's the same thing. F of x equals 2 to the power x is by alpha, and this symbol, which is closing the bracket symbol. And now press equal to. It's only one function table you're finding, so leave this as it is. Just press equal to. This is g of x. That means another function which is not there. Let's leave. Now I will take values from -5. Okay, starting value from -5 to where do you want? I'll take +5. Okay, and the step is also very important. Step 1 means I will get continuous numbers like 1, 2, 3, 4, 5, 6, like that. Whereas if I put step as 2, it will jump after 0, it will give me value of 2, x values will be jumped 4, 6, 8, and so on. If you take 3, it will be 3, 6, 9, and so on. So that's the thing. I'll keep it step as 1 itself and press equal to, you got the table. See, minus 3 onwards is there over here. It's 0 0.125, 0 0.25, 0 0.5, and so on. So this is the graph of the from this values, from the table of values. You can do it in the calculator and directly get it. Now, what is domain, range, y-intercept, asymptote, and behavior? By now you must know these topics because we have done it many times before. Let's quickly recall. Domain means x values, all the possible x values, whereas range are all the possible y values. Intercept, y-intercept means x is equal to 0, that is the value of y when x is 0. Asymptote is the new thing, that is over here where it approaches towards a line, towards a point, and end behavior is what is happening to the ends of the graph. Now let's see all of this. First thing, let's see domain. You can try putting any x values, any x value, and you will get an answer. Therefore, domain is all real numbers. You can see this graph is extended towards negative infinity, and over here also it goes towards positive infinity. It just keeps on going. So it's all possible values for x-axis. Domain is x-axis. All possible values, all possible real numbers, all real numbers, sorry. Range, you can see it doesn't dip less than 0, it's only till 0. It doesn't go less than 0. So it goes up all positive values but not negative ones. So it is only from greater than or equal to 0, greater than 0, sorry. So it's all positive real numbers. Okay, it can't be any negative numbers. And then y-intercept is 0 and 1. Now the y-intercept for any of the exponential function, what happens? Put any of the values. I mean, see, now when the base is a singular base like this and you have a power, say any number. Let me just go out. To go out from the table mode, it's more than 1. Now you're out. So let's take any number. Okay, any number like this to the power 0, because y-intercept is always when x is equal to 0. What is x? 0. Now let's press equal to. The answer is 1. Okay, for anything, any number, it will always be 1. Even for 2 to the power 0 is 1. Okay, so that is the y-intercept, 0 and 1. But if there is transformed, if they're transformed, it might change. Now we will see that in the coming problem. Now over here, asymptote, look at this. This part of the graph, this right side graph, is just going upwards. That's fine. It moves. But over here, y value keeps on changing until positive infinity. But look over here, left side, what's happening? It is approaching 0, isn't it? Though it does not touch this x-axis, it approaches towards it. So y asymptote is at asymptote is y equals 0. Why? Because it's at 0. And we have end behaviors. Always remember what's happening to the ends of the graph. At x is equal to negative infinity. So x equals, okay, this is negative infinity and this is positive infinity. What is happening? When x is negative infinity, the f of x value is 0. You can take a big negative number over here. Let's just try that. Let's take a big negative number, 2 to the power minus 100. It's almost 0 because there are 30 zeros over here, isn't it? 0.00000. After 30 zeros, it's 7. So it's almost equal to 0. So that's what you get. From the graph also you can easily see. And now look at what happens when it's at positive infinity. Here you can see it is going towards positive infinity itself, because if you increase this, say I will have I don't think so I'll get an answer for 100 because it's very, very huge. You will, oh, we get it. Okay, say 2 to the power 100 will be a huge number. There are 30 zeros, I mean 30 digit number, 31 digit number. It's a huge number. So it's infinity. Okay, that means it's going towards infinity, so we write infinity. I hope this is clear. This is the basics of the graph. Most of this we had already been through, only the asymptote is a new thing over here. So then we will see into another problem. Let's look at this. Now you can see it's all transformed. What's happened? There are so many digits, right? Don't worry, we will now quickly make use of Desmos because you'll get a better understanding of it. Now this is the exponential function. You can see all positive numbers, it's growth. Whereas let's see the decay over here from 0 to, say from here, from greater than 0 and less than 1, it's decay. You can see it's going downwards. Now what about 1? 1 means it's just a flat line because anything to the power 1 is 1. Okay, as you increase, it'll be over here. But that's not what we want. We know this is over here, 3 to the power x. The parent function is 3x. This is the one. We will remove this, okay? Now, if we just add a negative sign outside to it, what's happened? It's going downwards. It flips along the x-axis. Now, if I add negative to the power, you see it becomes again decay function over here. It flips along y-axis, okay? And then over here, if it's negative, see, if it's negative like this, right? But if it's negative outside, it goes down. So that's it. But we are mainly interested with this transformation. How about we transform this one by one? This is 3 to the power x, right? Now what I'll do is 3 power x, over here we have to multiply negative first, so it is going downwards, okay? And I have to multiply 0.5. When I multiply 0.5, what happens? I know it went downwards. There is only change in the y-intercept. Why is that? Because we know whenever 3 to the power x, the intercept over here 0, x is 0, it's 1, right? This entire thing is 1. Whatever number you're multiplying, whatever is the coefficient over here will be the y-intercept. If I have, say, 5 over here, negative 5, that means it's down, negative 5. If I have positive 5, it'll be 5. If I have 7, it'll be 7. So that's it, okay? That is an important thing to know. Let's go back, 0.5. So we have just transformed this part. Now, this is a basic thing, but these are very, very important parts. Now, before I do it over here, let me add any number. Look careful over here. This is a very important point because if we keep the measure along this, it's much easier, okay? Let us just add 5 over here. You saw the the original one. Let me just write this. Okay, the original function was over here, right? It jumped over here. What happened? It moved by 5 units. 1, 2, 3, 4, 5. If I had minus 5 over here, it would move down by 5 units. 1, 2, 3, 4, 5. That is the thing. Now, here, another way would be, look at the asymptote. Asymptote is 0, right? Minus 5 means the asymptote will become minus 5. Now, same way, add 5 over here, the asymptote will be positive 5. This is one way to understand. Okay, that's fine. What about this one? If I change value of x, let me change it to, sorry, plus 3. Okay, what happened now? Look carefully. Over here it was 0 and 1. Now you can see over here is minus 3. X value changes, not the y. So what happens is whatever is there, x plus 3 must be equated to 0 and solve for x. X is minus 3. So therefore this point shifts left side, 1, 2 and 3. If this was minus 3 over here, then it would have been x minus 3, that will equal to 0, x is equal to 3. See, now this is equal to, sorry for that, now minus 3. See, you can see from here it will shift 1, 2 and 3 to positive 3. Okay, I just missed it. Okay, again I missed it. Okay, it's over here, 3, 1. So this is what happens. So let me just take all this off and let's look back over here. Sorry, let me remove this. This was the original function, right? Now this was 0.5. Now I will quickly add, okay, up x plus 4. And now you can see there is at 0.5 over here somewhere. It will change. Okay, you can see that, right? Minus 4 at 0.5. Why? Because we multiplied 0.5, the intercept changes, and you can see over here now negative 0.4 and negative 0.5. From here, over here it was 0.5, it shifted. See, this is the point. I hope you get it. From here, 1 2 3 4, negative, because it's x plus 4, it will go to the left side. And lastly, it's plus 1, so the asymptote will be moved up by 1. So this is your final answer. This is the graph transformation for this. So you can see whatever we just now did, originally it was like this, it moved down, then it just changed a little bit, and it shifted left side and then went up by 1. So ultimately you get this answer. I hope this is clear. This is the graph transformation. Next, now you can also graph this directly by using table method. You can go to mode 7, type this over here, negative 0.5 multiplied by 3 to the power alpha x plus 4 and then plus 1. And now let's start with values. See, over here you must be little bit careful because it's plus 4. I know the graph is shifting towards left. So let me start these values, say from minus 10 until say positive 3. And step 1. Okay, now you will get these answers. So you can see minus 4, 1 2 3 4. At minus 4 it's 0.5, at minus 5 it's 0.89. see, and then at minus 3 it is negative, it dips down, right? And over here you can get all the answers. So this is the thing, this is the answer basically. Now this is also, you can check the graph, or you can if there are many options, right? If there are 4 options, just take a point which is easily visible, 1 2 3 4, like this point, and this point. Take the x value. What is this? Negative 1 2 3 4, negative 4. Instead of x, put negative 4, and you must get the answer of 0.5, negative or positive 0.5, and then that's correct. This equation belongs to this graph. Then you can check another point, say minus 3.5. Put over here instead of x minus 3.5, and it must be equal to 0. And same way you can put minus 3, and you must get the exact y values. So there are various ways to check this graph. Whichever is easy, just follow that. I just told all the ways, but whichever you find comfortable, just go with it. So that's about transformation. And now we are again, it's another same thing. So I will just quickly run through this. Over here you have a function, okay, and relates to this. Now what is the change over here? You can see the asymptote, the function f of x plus k. Okay, this is the real function f of x, so it will be something like this, right? Now, but in the graph, you can see it is the asymptote instead of 0 has moved down by 2 units. So this minus k must be minus 2. Why? Because it's moved down, right? That means it should be minus 2. So this is the answer. It's very simple. Now let's come to growth factor. This is an important thing. Now this equation over here is important because you might have real world problems on that. A, always the initial value. It can be initial population or initial anything, okay? Initial funds you have, initial value or initial amount. 1 plus R is always the rate of interest or percentage increase per time, okay? And T is time, that is basic. So growth factor is whatever inside the bracket 1 plus R. So that is the growth factor. It must be greater than 1. Otherwise, it cannot be a growth function. Whereas a decay factor would be minus. That's it. 1 minus and 1 plus. Now, let's see a problem. Mr. Lopez recently won the lottery. Suppose he takes the lump sum payment and invests $50 million into an account that yields 5% interest annually. Graph the function that models the amount in his account, then estimate the amount in his account after 20 years. Okay, now here they have used graphing calculator, I guess. Yeah, they have used graphing. We will try to solve for this. Okay, you can use the table of values, but over here it's a little bit hard because you don't have much to begin with for the graph. But let us use the formula which we just now saw a while ago. That is this formula. Here, what is the A value? A value is initial amount. It's 50 million. Million is 10 to the power 6. Okay, there will be 6 zeros. So I'll write it like this. A is that much. 1 plus, what is the rate of interest? 5%. 5% is 0.05. If you're getting confused with percent, phi, shift and over here, what is it? 0.05. Percent means divided by 100. So you're just divide 5 by 100. That is 0.05 to the power t. What is t? T is time. Time is 20 years. Okay, this is rate of interest annually, so this is also in year, so that's fine. Now over here, if you just put in the calculator, you will get what's the amount after the growth after 20 years. We'll just try this. 50 into 10 power 6 multiplied by 1.05. Just added it up. 1 plus 0.05 is 1.05 to the power 20. The answer is, oh, it's huge. It is 132,664,885.3 basically. If he invested 50 million, he will get so much after 20 years. Now that's the answer. After 20 years, this is what he's having. So in graphing calculators, you can easily get the graph for this function because this function can be graphed, and then you can get the table of values also, but you can do it even using our calculator, and that's the answer. Same answer. It's just 2/6 over here. It's, you know, simplified to 3. I mean, rounded off to 3. Here the same thing can be done over here. Now they're asking you, on a New Year's Day, Alma begins a savings plan. She saves $1 for the first day of January and increases the amount she saves each day by 1%. Find the growth rate, then use a graphing calculator to estimate all that. Okay, and the amount she should save on day 180 of a savings plan. Okay, after 180, how much will be the savings? Okay, after 180 days. So $1, I mean 1%, right? So you know what is the growth rate? 1 plus R. So 1 plus R is 0.01. So it's 1.01. This is your R growth factor over here. Now what happens after 180 days? That means initial amount 1 multiplied by 1.01 to the power 180. What is the answer? Okay, we need to use the calculator. 1.01 to the, because multiplied by 1 is the same thing. I'm directly doing this to the power 180. It's almost 5.99, $6. So the answers must be 1.01 and $6. So this is the answer. I hope this is clear. And now graphing exponential decay functions. Still now whatever we did was growth. Growth functions always grew, you know, became bigger as time passed by. As you increase x values, it increased. Now we will look into decay function, which will be decreasing. As the time passes by, it decreases. Okay, so the exponential decay occurs. Oh, this you just can read through this. Now the most important thing is the function. The formula is same, but 1 minus r whole power t, and decay factor is 1 minus r. So this is the thing. And always remember the base b must be 0 and 1. So this is the thing about decay functions. Let's now look into the problems over here. Sorry for the animation over here. Which of them represents? Okay, you need to say which are growth functions and which are decay functions. Looking at the given equations. 5 power x. Look at the base. It's more than 1. It's a growth function. 2 by 7. 2 by 7 will be 0 point something. So more than 0 but less than 1. So it's a decay. Okay. And over here 4 by 3 is 1.33. So it's again more than 1. Don't get confused because it's fraction. See, if you divide 2 by 7, it will be 0.285. Whereas if you divide this one 4 by 3, it's more than 1 because a bigger number is in the numerator. It is 1.333. It's a growth. Now 1.05 is more than 1, it's growth again. And we have 0.85, it's a decay function. I hope this is clear. It's very simple problems over here. So this is the answers. And now we will go to the example 6, that is to find the domain range and end behavior for a decay function. Now if you're thorough with the first part, you must be thorough with this. So now I request all of you to try it by yourselves. Pause the video now, take your time and make sure you solve it by yourself and then check with the answers, okay? Then continue the video. I hope you tried pausing the video. And now let's go through this over here. First, we can make the table of values. How we can make the table of values? From the calculator itself, mod 7, the function is 0.5, half is 0.5 to the power x. And press equal to, let's start with say -5 and end with 5. Step over here, these are the values. You can see at -2 we have 1 2 3 4, let's say that -2 is 4, -1 is 2, 1 is 0 is 1, 1 is 0.5, and so on. This is a growth function. And domain is all real numbers. It's the same thing. Domain is always real numbers, and range is all positive real numbers because it's more than 0. Asymptote is 0. Intercept is 0, 1. Asymptote is y is 0. And the end behavior is over here. When x is negative infinity, it goes towards infinity, f of x. As x tends to positive infinity, or x is approaching positive infinity, this means approaching or tends to, it's the same thing. The answer is 0. Y is 0. So that is the thing. And now the transformation. This you must do it by yourselves. Now please again try pausing the video. You can use Desmos to understand better, but please do this by yourselves. Over here, now I will continue obviously. See the transformation over here, it will be something, the decay, it'll be something like this. But since it's minus, it'll go like this. Now since it's +3, it'll jump up by 3 units. You can see it'll be, and since it's -4x equals 4, plus, it becomes +4, right? When you take it to the other side, it moves to the right. So ultimately, you can see there's a jump over here. There is a going towards the right by 4 units, and this is 3, and it's downwards. And the asymptote, the intercept will be always at 2. So this is all the transformation, how it's transformed. So that's the thing. And now we have exponential same exponential function, but we have piecewise equation. So piecewise equation means the domain varies for both the function. At this particular function, this is the domain, and for this function, this is the domain. So we need to graph that, okay? It's the same thing, you know what's the graph of half x, right? We just now did it, right? The same thing, but you need to stop it at -1, okay? Stop it at -1. You start graphing only till -1, don't extend it. And then it is over here a linear function. What is 2x plus 4? It is power 1, so it's linear. You can use the table to graph, but you know it will be something like the straight line because slope is positive. So you can graph it, make the table, you will get this. This is the exponential, this is linear. This is the first function, f of x. Now g of x is already given in the question. That is the part A, that is the first part to graph it. Very straightforward because we have done many graphing already now. Next, which of the functions, see now we have both the graph, which function has the lesser relative minimum? Okay, relative minimum. Now relative minimum means, now if you have a graph something like this, then the dipping point is minimum, the most above point is maximum, okay? Now if the graph is something like this, this is the relative minimum, okay? Because it's dipping like this. Though it goes towards infinity, that doesn't matter. Where it dips, or you have a curve like this, like a parabola, or like this, this is minimum, relative minimum. Now look at this graph. There is no relative minimum because, or maximum. It's just like this. It's not dipping like a U, okay? That is very important. The relative minimum in the first function, f of x, is at, okay, the relative value of relative minimum is 2, okay? But what about this? Over here, yes, at 2, something is happening. That's the asymptote. We can tell the asymptote is y equals 2 over here, whereas the minimum was at 2. But there can be no values less than 2. So all the values of the function values are greater than 2. That's about the minimum. I hope this is clear. And now part C, compare the y-intercepts and n behaviors of f of x and g of x. Now y-intercept over here is this point and this point. So you can see the y-intercept for f of x is 4. What about this? 1, 2, 3. 3 over here. It's 0, 4, 0, 3. It's understood. Now n behaviors as x is towards negative infinity over here, it's positive infinity. Even at positive infinity, it's positive infinity, because both are going upwards towards infinity. Whereas over here at minus infinity, it is 1, 2, and positive infinity, it is infinity, because it's going up. At minus infinity, it's at 2, you can see, and at positive infinity, it's infinity. So that's okay. That's the end. That's the end of this lesson. I hope you have found it useful. I hope you learned something new. And that's the end. If you have any doubts, any questions, please drop them in the comments. And if you're not yet subscribed to my channel, do subscribe. You can scan this QR code and subscribe it, or you can click on the link over here and just down over there, best math link, and do subscribe to my channel. It would mean a lot. Most important is you watch these videos and learn, and please do try working out problem by yourselves. Don't just watch the video, try solving problems by yourselves. Even the same questions or different questions from your textbook, solve it by yourselves, and then you will learn much better. All the best, guys, and please do stay tuned for the next video. I will try to upload it as soon as possible. Bye bye for now.